It actually is very closely related to what we've been working on the past couple of days with our exponential functions. So, in fact, it is an exponential function. So let's see, today is the 7th, so 7, 2, all right. So a geometric sequence is a sequence of numbers in which the ratio, which we are calling R, remains constant. A geometric sequence is a sequence of numbers in which the ratio R remains constant. Now, get that written down. I'll kind of explain what this means, and then we'll go ahead and just look at quite a few examples today, and hopefully we'll be able to get through this quickly, and you'll have plenty of time to work again today like we did yesterday. So, a sequence of numbers in which the ratio remains constant. Basically what that means, a ratio is a comparison of two values, and it's usually written as some kind of a fraction. And fractions can be whole numbers like 5/1. They could be negative numbers like -1/4. And so basically you are trying to figure out how to get from one number to the next. And that common ratio, that same number to get from one number to the next number, that constant value is what's known as the common ratio. And the common ratio is found by dividing, and this would be kind of the fraction portion of our ratio. Division and fractions are the same thing. Dividing each term by its previous term. So the common ratio, which is the thing that gets you from one number to the next, is found by dividing each term by its previous term. So the idea here, we'll go ahead and take a look at some examples so we can figure out how this works. Identifying a geometric sequence, we are going to determine, first of all, we have to actually figure out if something is a geometric sequence or not. So you're going to determine whether the following represents geometric sequences, and then if yes, identify what that common ratio is. And so in order to determine if it's a geometric sequence, we have to determine if there is a common ratio. And finding the common ratio, we just wrote here, we have to divide each term by its previous term. Meaning, if you start by dividing 10 by 2, this would be the term divided by its previous term. So 10 divided by 2 would be what? 5, okay. 50 divided by 10, so then you go to the next one and divide by the previous. 50 divided by 10 is what? 5. 250 divided by 50 is what? 5. So that would be yes, because there is a common ratio, and the common ratio R is equal to 5. Now, if you were to actually write that as a ratio, you would write 5/1, because a ratio technically is a comparison of two values. But if it's a whole number, you can just write the whole number. So for number 2, we're going to do the same thing. You don't start with the first number, you always start with the second one. So you're going to take 45, and you're going to divide it by 135. Which gives us 0.3 repeating, right? If you type that in on your calculator, and this is what our calculators are mostly going to be used for today, is this and using the formula that we see later. But this is just kind of checking to see if we have a geometric sequence. So 45 divided by 135 is 0.3 repeated. What is 15 divided by 45 equal? Same thing, right? Yeah, 0.3 repeating. 5 divided by 15, 0.3 repeated. Which, if you want to write this as a ratio, which you should, 1/3 would be your answer for that. Now, on your calculator, if you type in the division and it gives you a decimal like this, kind of like yesterday when or 2 days ago, when we were converting from fractions to decimals using this button here above enter, you can do that with a decimal to a fraction. So if you push this button right here, after you've done the division, you can see that it just gives you the fraction of 1/3. And when you write the ratio, because a ratio is a comparison of two numbers, it needs to be written as a fraction whenever you have a common ratio. So you're going to say yes, and then R equals 1/3. Use the fraction version, not the decimal version. All right. Let's check out number 3. 18 divided by 6. What does that equal? 18 divided by 6 is what? 3. Okay. 24 divided by 18. Does that equal 3? No. So our answer for 3 is no. 24 divided by 18 is going to be 1 point something. 1 1/3. So definitely not 3. And then 30 divided by 24 is 1.25. So there is no common ratio here. Every division of the number by the previous number gave us a different result. So the answer is no. This is not a geometric sequence. It's a sequence, but not a geometric one. All right, next one. If there are negative values, make sure you include those negative values. So this one here, negative 14 divided by 7 is negative 2. 28 divided by negative 14 is negative 2. Negative 56 divided by 28 is negative 2. So the result is the same each time. It gives us negative 2. So the answer is yes. And that common ratio is the answer to the division for every single one, which is negative 2. So I want you to do 5 and 6 on your own. Answer 5 and 6 on your own. Determine whether or not those are geometric sequences. If they are, yes, write the common ratio. If it's not, all you have to do is write no. So 5 and 6, take about a minute on that, work it out, see what you come up with. Problem number 5, what do we think? Yes or no? Yeah, I see some nodding, good. Yes, this is a geometric sequence. And what is the R value, the common ratio? What do we get here as a fraction? Negative 1/2, good. Negative 40 divided by 80 is negative 1/2. 20 divided by negative 40 is negative 1/2. Negative 10 divided by 20 is negative 1/2. All right. Number 6, is that a geometric sequence? Yeah, okay. And what is our common ratio? 4. Good. So to get from one number to the next, everything gets multiplied by 4. Okay. So the next 4 problems we're going to look at have to do with the fact that these are geometric sequences. It says, yes, they are. And what we have to do is figure out the next 3 terms in that sequence. So in order to figure out the next 3 terms, we need to know what the common ratio is and then apply that common ratio. So number 7, what is our common ratio on number 7? Negative 3, good, because negative 21 divided by 7 is negative 3. 63 divided by negative 21 is negative 3. Yes. All right, so then we're going to use that common ratio, r equals negative 3. And we're going to apply that to 63. So now we have to actually use this common ratio. So whenever you use the common ratio, you're going to take the number and then multiply it by the value of r. So 63 times negative 3 is the next number, which is negative 189. And then we can just type in times negative 3 again to get the next number, 567. And then times negative 3 again to get negative 1,701. So those are the next 3 values for that. Questions on that? You just take your r value, multiply, and it gets you to the next 3. All right, number 8. What's our common ratio on number 8? Anybody have that? The R value on number 8? Killian? 1/4, yeah. 768 divided by 3072. By the way, we don't need to check to see if this one actually is a geometric sequence because it tells us that it is. Gives us 0.25, push the button above enter, and that says 1/4. So that's our common ratio, 1/4. Now that we have 1/4, we can multiply that by this number here, 192. And that gives us 48. And when it's a fraction with a numerator of 1, you can either multiply by that number or you can just divide by the denominator. Either way, if the numerator is 1. Otherwise, you have to multiply by the fraction. 48 times 1/4 would be 12, or 48 divided by 4. 12 times 1/4 would be 3. So the next three values are 48, 12, and 3. So geometric sequence could be increasing or they could be decreasing. Or in the case of 7, it's increasing and decreasing at the same time because it's being multiplied by a negative, which actually just means that it's getting further and further away from 0 on both sides of the number line. All right, number 9 and 10. I want you to work on those two on your own. Try 9 and 10. Figure out the value of R, and then use the value of R to determine the next three values. Yes, let's see. Elena. They want to talk to you. All right, so number 9, what is our common ratio for number 9? Gabriella, what did you get? 1/2, yeah. So common ratio, 1/2. So everything gets multiplied by 1/2 or divided by 2 from 1 to the next. So what's our next number after 2? 1. And then what's after 1? 0.5 or 1/2. And then the last one would be what? 1/4, yeah. So 2, 1, 1/2, 1/4. So we're just cutting everything in half there. The last one here for number 10, what is the ratio on number 10? 5, yep. So everything gets multiplied by 5. So negative 125 divided by 5 is what? Killian? negative 625 followed by negative 3,125. And then finally, negative, pretty big negative. Anybody else have it? Yeah, negative 15,625. Cool. All right. So hopefully so far this, I can't imagine would be really any more challenging than what we did yesterday up until this point. And in fact, it's actually not going to get really any more difficult. We are going to use a formula, but the interesting thing about this formula is that it's the same one we've been using the last 2 days. Again, it's going to take a little bit of a different form than what we've seen the last couple of days, but it still is the same formula. And I'm going to show you kind of a side-by-side of all 3 of them after I write this one here. And this one is a to the n, or a sub n. This is an n. This is a tiny little n, kind of like where you have an exponent. This one is down below. It's sort of like with our slope formula, with our, sort of like when we have our slope formula and we say like y2 minus y1 over x2 minus x1 with the numbers down here. Same thing up here. It's basically saying the term number is what this is going to be. So it's like, hey, find the 4th term in the sequence. And so that would put a 4 in for n. We'll talk about how to do that in a minute. So this is just saying a with an n down here. It's not to the n power because it's down to the side. But this is basically the same thing as y. This a and the n down here is like having a y. And then this is going to equal a with a 1 down there. So basically the first term, that's what that means. Sort of like y1 was the first y value. A1 is the first term in the sequence. And then we're going to multiply that by r. And then the exponent is to the n minus 1. Now, this looks pretty different than what we've seen in the last couple of days, but it's actually the same formula. The one that we saw a couple of days ago was right here. Y equals a times b to the x. So this a with the n is the same as the y. This a is the same as the a with the 1. The b is the same as the r. And the value of x is the same as this n minus 1. So it's the same formula, it just takes a different form because we're using it in a slightly different way. Yesterday, we kind of did the same thing, used the formula in a slightly different way. But it's still the same formula. It's multiplying a number by another number that's taken to a power. So it's 2 numbers multiplied together with the second one taken to an exponent of something. And so it's the same exact idea with what we're looking at here. So the an is the number, the nth term is what we would call that. A1 is the first term. So A1 is the first term. And then R is the ratio. And then N is the, we'll call this the target term number. So it's the term number that we're looking for. So we'll call that the target term number. That's what we're going for. That's what we're aiming for. So our examples begin with number 11 down here, and I think we can see those. And that's 3, 9, and 27. It's a little bit challenging to see, but it's a 3, a 9, and a 27. And it says write the rule for the nth term. The nth term would just be a generic formula. And then we are going to find the 7th term in the sequence. A7 would be find the 7th term in the sequence. So the generic formula here, we're just going to use n instead of an actual number, but we still need r, and we still need a1. So let's write out what those things are first. So what is a1 here? A1 is always easy to figure out, the first term in the sequence, which is 3. So a1 here equals 3. R is the common ratio. We need that. So how do we get from one term to the next here? Multiply by 3. Yep. So R equals 3. And so our formula for the nth term is just a generic formula. We're going to write a n equals We're just filling in for these things here. A1 we have, that's 3, times R, which is also 3. And then that's going to be to the n minus 1 power. And so that would be writing the rule for the nth term is this here. Then what it says is find the 7th term. That's what that means. A7 would be find the 7th term. So what we're going to do is anywhere we see n, we're going to write 7. So we're going to write A with a 7 down there equals 3 times 3 to the 7 minus 1 power. And we can subtract those exponents up here. 7 minus 1 would be 6. Or you can just type that directly into your calculator and get your answer. Either way. We can type that in exactly as it is right here. 3 times 3. And then exponent 7 minus 1. You can type it in exactly like that. And that'll give us our answer. And so if we hit enter, that says 2,187. So the 7th term of the sequence, A7, 7th term of the sequence, A7 equals 2,187. So it's using the formula, writing a formula, plugging things into it, and then just using our calculator to do the math for us. All right, let's try the next one. If there's questions on this, please let me know. Number 12, that's a -4, a +20, and a -100. So -4, +20, -100. The first term here, you should always be able to do the first term, -4. The ratio as well, the common ratio is going to be what on this one? What's our common ratio? Killian? -5, yeah. So if you take the next term, 20, divide by the first one, -4. 20 divided by -4 is -5. So this is enough information here to write our rule for the nth term. So that would be an equals -4, that's A1, times the common ratio, -5, to the n minus 1. Now, when you use exponents on a calculator, it's actually always a good idea, and I'm going to put them around the 3 on this first one as well. It's always a good idea to put the number that's taken to an exponent in parentheses, and it's especially important to do that if that's a negative number. So please remember to do that, because if you don't, it will not give you, in many cases with negative values, it will not give you the right answer, or at least the answer that you're looking for. So just get in the habit of, if you take a number to an exponent on your calculator, put it in parentheses. That's just a good rule for positives and negatives, because then you will be guaranteed to get the right number. So we're looking at A7 now, because we're trying to find the 7th term. And that's going to be -4 times -5 to the 7 minus 1, which is just 6. And you can just write, you could write the result of the subtraction. You don't have to write the 7 minus 1 or the 10 minus 1 or whatever that is minus 1. You can just write the result of what happens when you subtract 1. And so we're going to end up here with -4 times, in parentheses, -5 to the 6th power. And that gives us -62,500. So the 7th term in the sequence, -62,500. All right, any questions there before we look at the second page? This is what we're going to be doing most of the rest of the time here, is using our formula. All right, get that written down, and we will move on to page 2. All right, there are 6 problems to do here. I would like you to work on the next 4 on your own. Work on 13, 14, 15, and 16. Solve those next 4 problems on your own, and then in a couple of minutes, we'll come back and check those. Make sure you're getting them good, and then we will move on to the final few questions after that. And these are still carrying on from the last page, so write your function rule and then find the 7th term. Notes right there. The first page, so you can just copy down. Just bring those back up when you're done. All right. The delivery truck. Our notes right there. All right, so with 13 through 16, let's go ahead and check those out, see how we did. Number 13, we end up with 6 1/4 or 6.25. either way. If you went with 25 fourths, that's fine too, because I think that's what the calculator gave as a fraction. And then number 14 is 15,625. 15 is negative 4,096, and 16 is 1, which is kind of interesting. Are there any questions on those four that we need to take a closer look at? We've got our first terms and our common ratios. The first terms, again, you'll always be able to get first term. Common ratio, you got to figure out, using a little bit of division to do that. So our common ratio on 13 is 1/2. Common ratio on 14 is 5. On 15, it's 4. And on 16, the common ratio is negative 1/3. And so that's where we get the rest of those formulas there. Our generic formula with n, and then everything else when we plug in 7 for n, that gives us an exponent of 6 on each one of these to get those final answers. So questions on those before we look at the final 4 problems? All right, 17, here we go. Our first term, a1, that is 6. Our common ratio on number 17 is what? -2, good. So that will give us a formula of an equals 6 times -2 to the n minus 1. Which would be, if we're finding the 7th term of the sequence, that would be a7 equals 6 times -2. 7 minus 1 would be to the 6th power. And if we multiply that all together, the 7th term equals what? Who's got it? Anybody? What is our 7th term on number 17? You got it? Gabriella, what do you have? 384, good. 384 is our answer for number 17. Okay, final one here. A1 equals 8. Common ratio. Do we have that? Number 8. Gillian? 3/2, yeah, 3/2. So it's a fraction, it's an improper fraction, it's greater than 1. 3/2, you could use 1.5 if you want, because it's a nice decimal, but we'll keep this as a fraction, because the ratios usually get written as fractions. And so we'll have our formula as an equals 8 times 3/2 to the n minus 1. And then go ahead and find the value. You can use a decimal for the final answer if you'd like. What do we think? A7 would be 8 times 3/2 to the 7 minus 1, so to the 6th power. Gillian, what'd you get? 91.125, yeah. 91.125. So, or 91 1/8. Either way, that's fine. We got 2 more problems that both are related to Both are related to kind of a little bit of a word problem here. So our application problem down here says, this is sort of it's another depreciation question, but we're actually using a table of values to figure this one out. So we talked about depreciation yesterday with car values on some of those examples that we saw. And it says the table to the left shows a car's value for 3 years after it's purchased. And so year one, it says was worth $10,000. Year two is $8,000. Year three is $6,400. Write a rule to represent the car's depreciation. So that's going to be our general rule with the N. And then after that, it's asking us what the value of the car is after 10 years if that pattern continues. So on number 19, we're just going to start off by figuring out, okay, what's the first term in our sequence? So what is the first term in our sequence here on number 19? What does A1 equal? 10,000. Yeah, so these are our sequence terms here. So A1, 10,000. And then we need the common ratio. So you take the next value and divide by the previous value. So what's that? 4/5, yeah. And that should also be the same for 6,400 divided by 8,000. And it is, and the reason, and first of all, the reason why we only need to do this first one here is because it didn't actually ask us to figure out if this is a geometric sequence, so we can kind of assume that it is one. So 4/5, it's losing a little bit of value. So R equals 4/5, and so our first, number 19, our first problem here of this application is write the rule, which would be that AN rule. So that's going to be 10,000 A1 times the value of R, 4/5, to the N minus 1. So that's the rule that we're going to use to solve for how much the car is worth after 10 years. So 10 years would be find out what A10 is, the 10th term in the sequence. So we're going to say A10 equals 10,000. Good morning. Times 4/5 to the, what power are we going to use here? The 9th power, yeah. 10 minus 1 would be to the 9th power. All right. So the value then, after 10 years, we're going to use dollars for this because we're going with the value of the car. We'll get it typed in, 10,000. And then fraction, 4/5, close the parentheses, all to the 9th power. That's what we're looking at right there. How much is the car going to be worth if this depreciation trend continues? What'd you get, Killian? I think you might have left off a 0. Okay. So 1342.17. That sound right? It would be 18. Because that second 7 will round the first one up to an 8. Yes, 18. Good. So $1,342.18. And that is it for our final lesson of this unit. So I'm going to give you the assignment for this lesson, and then tomorrow we are going to do a review of the last 3 days worth of lessons, and then we will have a quiz on Monday.